everyone, welcome to another episode of Quick Math Tutorial. Today, we are going to learn about independent and dependent events. First, let's define what is independent events. Independent events in which the probability of any one event occurring is unaffected by the occurrence or non-occurrence of any of the events. The formula for this is the probability of A and B equals the probability of A times the probability of B. For example, you will randomly pick a card in a deck of cards, returns it, then randomly pick another card. It is independent event because it does not affect the occurrence or non-occurrence of any of the events. Since you returned the card, therefore, the number of cards is still the same. Now let's have dependent events. Events in which the occurrence of one event does affect the occurrence of the other. For its formula, we have the probability of A and B, which is equal to the probability of A times the probability of B following A. For example, you will randomly choose a candy in a jar, eat it, then randomly pick another candy. It is dependent events because it affects the occurrence of the other event. Since you ate the candy, therefore, the number of candies in the jar decreased. Now let's have our first example. For our first example, we will just identify if the problem is dependent events or independent events. So we are given here 3 black ball pens, 2 blue ball pens, 1 red ball pen, and a total of 6 ball pens. So first, we will find the probability of getting a black ball pen, returns it, then gets a blue ball pen. So this problem is independent events because of the words returns it. Second, we will find the probability of getting a black ball pen then gets a blue ball pen without replacement. So this problem is dependent events because of the words without replacement. For our second example, we will solve this problem. A bag contains 6 black marbles, 9 blue marbles, 4 yellow marbles, and 2 green marbles. A marble is randomly selected, replaced, and a second marble is randomly selected. Find the probability of selecting a black marble, then a yellow marble. So for our first step here, we will identify if this problem is dependent events or independent events for us to know what formula to be used. So this problem is independent events because of the word replaced. Now, our next step is to list all the given. So we have 6 black marbles, 9 blue marbles, 4 yellow marbles, 2 green marbles, and a total of 21 marbles. So we are asked to find the probability of selecting a black marble, that will be our event A, then a yellow marble, and that will be our event B. So the formula for independent events is the probability of A and B, which is equal to the probability of A, which is our black marble, times the probability of B, which is our yellow marble, equals the probability of selecting a black marble is 6 over 21. 6 since we are given 6 black marbles over 21 since the total number of marbles is 21 times the probability of yellow marble is 4 over 21. 4 since we are given 4 yellow marbles over 21 we have the same denominator since in this problem, the marble was returned. Therefore, the original number of marbles is still the same. Next, we will multiply 6 times 4, which is equal to 24, 21 times 21, which is equal to 441. Or in lowest term, we will divide both sides by 3. So we have 8 over 147. Therefore, the probability of selecting a black marble than a yellow marble is 8 over 147. For our third example, we have a box of chocolates contains 10 milk chocolates, 8 dark chocolates, and 6 white chocolates. Hannah randomly chooses a chocolate, eats it, and then randomly chooses another chocolate. What is the probability that Hannah chose a milk chocolate and then a white chocolate? So first, let's identify if this is independent events or dependent events, for us to know what formula to be used. So this problem is dependent events because of the words eats it. Now, we will list all of the given. We have 10 milk chocolates, 8 dark chocolates, 6 white chocolates, and a total of 24 chocolates. We are asked to find the probability of choosing milk chocolate, and that will be our event A, or white chocolate, and that will be our event B. So the formula for dependent events is the probability of A and B, which is equal to the probability of A times the probability of B following A. Next, the probability of choosing a milk chocolate is 10 over 24. 10 because we are given 10 milk chocolates, and 24 because the total number of chocolates is 24, times the probability of white chocolate following the milk chocolate. So we have 6 over 23. 6 because we are given 6 white chocolates over 23. Since in this problem, the chocolate was eaten, therefore, the original number of chocolates was reduced to 23. Suppose Hannah already ate 1 milk chocolate. So instead of having a total of 24 chocolate, so it will be reduced to 23 chocolates. Now, let's multiply. 10 times 6 is 60. 24 times 23 equals 552. Or in lowest term, we will divide both sides by 12. We have 5 over 46. Therefore, the probability of choosing a milk chocolate or white chocolate is 5 over 46. And for our last problem, we have a box contains 7 white marbles and 7 red marbles. What is the probability of drawing 2 white marbles and 1 red marble in succession without replacement? So therefore, this problem is dependent events because of the words without replacement. Now let's list all of the given. We have 7 white marbles, 7 red marbles, and a total of 14. We are asked to find here the probability of drawing 2 white marbles, our event A, and 1 red marble, our event B. So now let's have the formula, the probability of getting white, white, and red equals the probability of white times the probability of white following white times the probability of red following white equals the probability of getting white is 7 over 14. We have 7 because we are given 7 white marbles over 14 because the total number of marbles is 14. Times 6 over 13. Suppose we already got one white marble. Therefore, instead of having 7 white marbles, we are left with 6 white marbles. And also, the total number of marbles was reduced into 13. Times 7 over 12. 7, since there are still 7 red marbles in the box, over 12. 12 because we already got one white marble and another one white marble. So we are left with 12 marbles. Now let's multiply 7 times 6 times 7, which is equal to 294, and 14 times 13 times 12, which is equal to 2184. Or in lowest term, we will divide both sides by 42. We have 7 over 52. Therefore, the probability of drawing 2 white marbles and 1 red marble is 7 over 52. And that ends our quick math tutorial. If you liked the video, please click on the like button. If you have questions, just leave a comment below. And to be notified on my new videos, don't forget to click on the subscribe button. Bye!
Tell me pretty lies, look me in the face. Tell me that you love me, even if it's fake.